Alright, hello ladies and gentlemen. Today what we're talking about are patterns. And when we're talking about these patterns, what we're going to talk about is actually writing a function from a pattern. The first thing we're going to talk about is this little idea here. And what's going on here is we're trying to figure out the number of line segments given a certain number of dots. Now as you look at this layout we have here, the first column we have here, the term number, which we call in this case for this situation the number of dots. That's your independent variable, your domain, your x-coordinate, what you need to know to begin with. What we're trying to find is, again, your range, your dependent variable, that y-coordinate, which is the number of line segments. So, visually as we look at this, if you have a line with one dot on there, you end up with 2 line segments. 1, 2. 2 dots give you 1, 2, 3 line segments. 3 dots gives you 1, 2, 3, 4 line segments. And you can go down and you can start figuring out some of the other ones. If you put on 4 dots, 1, 2, 3, 4, you can figure out, obviously, you're going to have 5 line segments. Now, the idea is to be able to figure out the process that it takes to get to that point. When we talk about that process, this is something you've done before. What you're going to have to start off with is you're going to have the change that is made multiplied times the domain. And then what we add on is our initial value, our constant. Right? How we write our functions. Alright, now, as we look at this, what we're going to talk about is in terms of n. So to start off with, when we look at this, the first thing you need to find is what we call our rate of change. And you've done this before in the past. And what we're going to do is just find our change and our value of y. As we look at this, each time we only add on 1 each time. Alright? So our value for our change is 1. We multiply that times the value of x. Well, 1 times 1 is 1. Well, what you need to figure out is what you're adding on to, your constant. Okay? So 1 times 1 is 1. Well, 1 plus what gives you 2? Well, 1. For the next one, 1 times 2. 1 times 2 is 2, plus what is 3? 1. Plug in a 3. 1 times 3 is 3, plus what is 4? As you can guess, 1. Your constant is always the same. What we're changing is your domain to get a range. So we look at this in terms of n. That's 1 times n plus 1. That is your pattern. N is your domain, your x-coordinate, your independent variable. Alright? Alright. So, let's take a look at another one. So we'll look at this pattern. The idea of this pattern is, first off, you have a certain number of cubes. Alright? And we have a couple of you get some visualizations here for it. What we're trying to figure out is your dependent variable, your y-coordinate, the number of faces to paint. So what you're doing is you're painting some of these cubes that's sitting on the ground. So if it's sitting on the ground, when you look at this, if you have one cube, you have 1, 2, 3, 4, 5 faces to paint. You don't paint the 6th side because it's on the ground. So your dependent coordinate, the y-coordinate in this case, is 5. So if you plug in a 1, you should get a 5. For the second one, we look at this. If you have 2 cubes stacked on top of each other, 1, 2, 3, 4, 5, 6, 7, 8, and then the top one, which is 9. So you get 9 faces to paint. Third one, 3 cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright? Now, one of the things I want you to start noticing is the pattern that it's forming. So for every cube you add, how much are you adding to each number of faces? Well, from 5 to 9, that's 4. From 9 to 13, it's 4. So that's a pattern that is forming. So you can assume that for 4 cubes, you should add 4 more faces to paint, which would give you 17. So, if we find the process, the pattern, the function that we would use to do this, again, the change is going to be 4. Changing by 4. Multiplied times the number of cubes. Well, 4 times 1 is 4, plus whatever the constant is. Well, to get to 5, you got to add 1 onto it. For 2, that's 4 times 2 plus 1 gives you 9. For 3, 4 times 3, that's 12, plus your constant gives you 13. And then for your last one, 4 times 4 plus 1 gives you that 17. In terms of n, all we do is we replace the domain, which is what we plugged in here, with an n. So now you have the function. That's the pattern that is happening. All right. Any questions? Well, I guess you can't tell me now. If you got any other questions, ask me about this in class. That should help out quite a bit. Next one. That same exact set. What does it look like in a table? Real simple. Number of cubes is your x-coordinate. Number of faces is your y-coordinate. Okay? All of this right here. 1, 2, 3, 4, and the n, that is your domain, your x-coordinate. So if you were looking on a table in your calculator, this is what it would look like. The only thing you wouldn't have is the n. The range is the 5, the 9, the 13, and the 17. And this is your function. Right? So, the big question is, what does the 0.29 mean in this situation? Just what it says. 2 cubes means you need to paint 9 faces. That is the whole idea. That's the whole idea of this whole subject. Take a set of data and be able to put meaning to it. Alright. So, we've got another one here. So, here's your visual. First thing. Term numbers. So, this is your domain. We're trying to figure out the number of line segments. So if you got one box, that's what we have here, one square. How many number of line segments for each one? 1, 2, 3, 4. There you go. For number 2, there's 2 boxes. 1, 2, 3, 4, 5, 6. 6 of them. For the next one. For 3 boxes, 1, 2, 3, 4, 5, 6, 7, 8. So that gives us 8 segments. Now, from here, you can figure out your pattern. The first thing is, figure out the rate of the change. So every time you go through this, how do you get from 4 to 6? 6 to 8. Your change right now is going by 2. Times the domain. Well, what's 2 times 1? It's 2. So what do you have to add on to get to 4? Another 2. So 2 times 1 plus 2 gives you 4. Plug in a 2. 2 times 2 is 4. Plus another 2 gives you 6. Plug in a 3. 2 times 3 is 6. Plus 2 is 8. So for the value of x, for this one, instead of writing a 3, we write an x. So 2 times x plus 2. That is your pattern that you're showing. Now, the reason why we have these patterns is to be able to predict. Because in life, we don't just have nice, easy 1, 2, 3 numbers. We have larger numbers. You might even have them in the thousands, the millions, who knows? But let's predict. What would happen if you have 56 boxes? If you have 56 boxes, you take that 56, you substitute it in for x, and you solve that. So as you look at this, 2 times 56 gives you 112. Plus 2, so 112 plus 2 gives you 114. So you can assume that if you have 56 boxes, you're going to end up with 114 line segments. That's the whole idea of these patterns, is your ability to be able to predict what will happen later. So, next part. This is a little review, but I want to make sure we remember this. If you're given a table, which function matches the table? Remember how we talked about this? Where would you go on your calculator? Go straight to y is equal to. So if you go to y is equal to, what you want to do is you want to plug in a function, let's say c, negative 4x plus 21, and you want to check the table. See if that table matches your function. Negative 125, 0, 21, 117, 4, 5. So yeah, you have to check through those. I would choose, in this case, C. Alright? When you're at school, you can try A and B, but you'll find they will not give you the same values of X and Y. Your domain will not match your range. For the next one, same basic idea. Except for now we have A and C. So you got to think, which one's your X, which one's your Y? Well, that's what we talked about, independent and dependent variables. Your dependent variable is always the one that is by itself when we look at these. It's the one where we're trying to find the answer. The X value, your independent variable, your domain, is the one that's in the function. So your X coordinate is the A in this case. The Y coordinate is the C. So, when we're looking at this, we want to see which one of these matches. So again, you go to y is equal to on your calculator, and what you'll do is you'll plug in one of those three functions. Now, I'm going to choose B to start with. Remember, if you have 1/2, you can't put in 0.5, but remember, if you're going to write a fraction into the calculator, a fraction is a division problem. And we put that fraction inside of a set of parentheses. And from that, we will type in the rest. We cannot type in an A, so instead of writing an A, since we know this is our domain, we type in an X. And then -7. Press second, and then you'll press the table and you'll look. And for our values, -2, -8, 2, -6, 6, -4, and then 7, -3.5. There you go. So, as you look at this, B works for this one. You can try the other ones and you'll see they won't work out. But I want to make sure we remember this when we have a test, we have an assignment, you have a quiz. Alright. Again, go back and look any of this over. Pause at any point when you guys are doing this. If you have any questions, bring them to class. Alright, you guys have a good evening. Bye.